So remember when we started graphing quadratic formulas? They look like, do you guys remember what the graph looks like? Starts with a P, parabola. It looks like this. Okay, and then a problem would look something like x squared plus 3x plus 2. You guys remember these? How did we solve these? We had several methods. What was the one that we mostly used? Diamond method, right? Okay, that means that all of these ended up being factorable, right? Remember when we were doing the factoring stuff? There was also diamond method and bottoms up and difference of two squares, and then we learned the special one, which was perfect square trinomials. Okay, those are all, we were able to factor all of them, right? What we're going to be working with today and tomorrow are ones that we cannot factor. So what happens when you can't factor it? Before we used to say, well, but bottoms up was factorable too, right? We were able to split it up. We were able to break it apart. What we're going to be working with today and tomorrow, we are not going to be able to break it apart at all. You can't use bottoms up, you can't use diamond method, so we're going to learn a couple new methods. That's mostly tomorrow. What we're going to be doing today is kind of introducing that and getting used to it. So we're going to be solving quadratic equations when there's an x squared all by itself on one side. Nothing else, just x squared. Okay, so step one, what we have to do to solve the quadratic is first we need to divide to get the x squared term by itself. And then underneath I have, or next to it I have written if necessary. So that means that sometimes it's not going to be necessary to divide, because sometimes x squared will already be by itself. Okay? Okay, step two, you are going to, since we are going to be left with a squared term, the opposite of squaring something is taking the square root. So you need to take the square root of both sides. And then there's something really important that I wrote in all caps underneath it. Make sure your answer is plus or minus. Let's look at this. If I tell you that the answer to x squared equals 4 is equal to 4, okay, so I have x squared is equal to 4. How would I solve for this one? I take the square root of both sides, right? That squared and that square root cancel each other out. So I get x equals what? What's the square root of 4? 2. Could the answer be negative 2? If I plug negative 2 back in, what's negative 2 squared? Positive 4. What's positive 2 squared? Also positive 4. So whenever we are the ones taking the square root, as in we're the ones actually drawing in the square root to use as the opposite, our answer is always going to be plus or minus 2. If I am the one that has to draw the square root to make sure that, to get rid of that squared term, my answer is going to be plus or minus, always. That's why all of our problems so far have been plus or minus. Does that make sense? Okay. The last step is you are going to solve for x if necessary. So sometimes after you take the square root, we'll be solved for x and done. Sometimes there'll be a couple more steps to getting x by itself. Okay? That's pretty much all we're going to be doing. So let's just do a bunch of examples to get used to this. Example 1, I have k squared equals 49. Is the squared term by itself already? Yes. So what do I need to do to get k by itself? Square root it. Good. So let's take the square root of both sides. So that's going to be k equals. Now, was I the one that drew the square root in there? Yes, so my answer is going to be plus or minus 7. And that's it. Let's do a quick mental check. Positive 7 squared gives me 49, and negative 7 squared gives me 49. So we got the right answer. Okay, that's an easy one. Let's look at example 2. 2x squared equals 8. Is the x squared term by itself? No, there's that 2 attached to it. How do I get rid of that 2? Divide both sides by 2. So we want to have x squared by itself, nothing attached to it anymore. What's 8 divided by 2? 4. Okay, now what? Take the square root, which means I get x equals plus or minus 2, because I'm the one that took the square root, that drew it in. Does this make sense so far? Okay, what about example 3? There's several steps that we have to do first. We have to add 15 first. We need to get rid of that minus 15. So let's add 15 to both sides. So that gives me 4y squared equals 16. Do I have y squared by itself yet? No. So divide both sides by 4. Y squared equals 4. Now what? Square root. So I get y equals?
Plus or minus 2.
Plus or minus 2. Good job, guys. So y equals plus or minus 2.
I think it's the top one.
Okay, example 4. 4. First thing I have to do is what? Get x by itself. So let's get rid of that 9. So that gives me x squared equals negative 7. Okay, now what? Square root. Why can't I do that? Because it's negative, so no solution. Good. Really quickly, if I were to factor this side, what rule would I use? X squared minus 9. That is a difference of 2 squares. Good. Okay, example 5. What do I do first? Divide by 64. So that means p squared equals, okay, 4 divided by 64, how does that reduce? No, 4 goes into 4 once, and 4 goes into 64? 16, right? So this is 1 over 16. Okay, now what? So we have to take the square root of both sides. So that means p equals, and we can split this up, right? Plus or minus the square root of 1 over the square root of 16. Mine got kind of squished. So this is equal to plus or minus, what's the square root of 1? 1, so 1 on top over 4. So plus or minus 1/4. You can take the square root of a fraction. The only thing we cannot take the square root of is a negative. You have to put plus or minus. Okay. Moving right along. Example 6. Okay, x plus 2 in parentheses squared equals 81. Question, is the squared term by itself? Actually it is, because this whole thing is in parentheses, so they're all attached, right? So whenever we have parentheses squared, we can just take the square root of both sides. So that square root and the square cancel. So on the left, I'm just left with x plus 2, whatever was inside the parentheses. Equals? Not 9. Plus or minus 9. Okay, now what? Subtract 2. This is what I mean by solve for x if necessary, because there's an extra step. So that's x equals negative 2 plus or minus 9. I can't leave my answer like this, because I can actually do this, right? We have two answers here. We have x equals negative 2 plus 9, and x equals negative 2 minus 9. That's what the plus or minus means. So what's negative 2 plus 9? Positive 7. And what's negative 2 minus 9? Negative 11. So I have two answers here. X equals 7 and negative 11. So if you are given or end up with plus or minus two numbers that we can actually put together, do them and you should get an answer. Okay, you should be able to go all the way down. So technically, when we have plus or minus, like in number 5, I have plus or minus 1/4. How many answers are there really? 2. Positive 1/4 and negative 1/4. But because they're the same, we only have to write it as plus or minus. When we got x equals negative 2 plus or minus 9, we could actually carry that further, so we split it up into two equations. Does that make sense? A little bit? Let's try another one. Example 7. Y minus 15 squared equals 8. Is the squared term by itself? Yes, it is. So let's take the square root of both sides. Those guys cancel, so I'm just left with what's inside the parentheses, which is y minus 15 equals. Can I take the square root of 8? No. Can I simplify the square root of 8?
Yeah, 4 times 2.
Yeah. That's same as the square root of 4 times 2, and the square root of 4 is? 2. Now, because I took the square root, my answer has to be plus or minus 2 root, what was left inside? 2. Okay, did I solve for y yet? No, so let's add 15. So y equals 15 plus or minus 2 root 2.
Oh, wait, why wouldn't you add the 2?
Okay, well, hold on. Okay, why did I not add 15 and 2? Can somebody explain it to me? Julia? The 2 is attached to the square root. This is 2 times the square root of 2. So these guys are not like terms. This is an integer, and this is what is this? This is a root. Integers and roots are not like terms. So we just leave our answer as 15 plus or minus 2 root 2. The only reason why we actually added them in number 6 is because they were both integers. There were no square roots in there. Okay, if there's a square root attached to the number, you cannot add it with the integers. They are not like terms. So you just leave it like this. How many answers technically are here? Just 2. 15 plus 2 root 2 and 15 minus 2 root 2. So just 2 answers. But we don't want a decimal as our answer, so we just leave it like this. Okay. We're going to take it one step further in example 8. Looking at example 8, is the squared term by itself?
No.
No. Why?
Because
of the 3. So I need to get rid of that 3, right? So what do I do? Divide by 3. No, we can't distribute because the x plus 1 is being squared. So this is x plus 1 squared equals 27 divided by 3? 9. Now is the squared term by itself. Yes, so let's take the square root. So my answer is just what's inside the parentheses, x plus 1, equals square root of 9.
3.
Plus or minus 3. And then we subtract 1. Now, should I write this as two equations? Can I combine these terms?
Yes.
Yeah, they're both integers, right? Okay, so this is x equals negative 1 plus 3, and x equals negative 1 minus 3. So x equals negative 1 plus 3, 2. And x equals negative 1 minus 3, negative 4. So we have 2 and negative 4 as our answers. It does not matter the order. Okay, so example 9. Is the squared term by itself? No. So what do I have to do to get rid of that 2? Divide by 2. Good. So this is x minus 5 squared equals 40 divided by 2? 20. Now what? Square root it. So my answer is just what's inside. So x minus 5 equals, okay, I took the square root, so I know it's going to be plus or minus something, right? So let's write that in right away. How can I rewrite 20 using a perfect square? 10 times 2, but that's not a perfect square. 4 times 5. So that's the same as square root of 4 times square root of 5. And what's the square root of 4? 2. So that is 2 root 5, right? So plus or minus 2 root 5. Does writing this out help you guys?
Yes.
Okay. Okay, now what? Add 5 to both sides. So that is x equals 5 plus or minus 2 square root 5. Can I add 5 too? No, they are not like terms. So that's your answer.